Find x. There it is. Ah! This is a right triangle. And we are being asked to find the missing side of a right triangle. And whenever you're being asked to find the missing side of a right triangle, you use a little old guy called Pythagorean Theorem. A squared plus b squared equals c squared. Now, what's what? Well, to be honest, it doesn't matter which one A or B is, as long as your longest side is C. C is the hypotenuse. C is always going to be the side not attached to your right angle. So C has to be 13 in this case. Which one has to be A or B? It doesn't matter as long as the longest side is C. So I'll call A 12 and I'll call B X. Now you substitute these numbers and that variable in here and do a little bit of solving. A is 12, so 12 squared, plus b is x, so x squared, equals c is 13, so 13 squared. Now the next thing that you do in Pythagorean Theorem is you simplify the numbers. So 12 squared is 114, plus x squared is still x squared, and 13 squared is 169. In order to get x all by itself, I have to subtract 144 from both sides. So minus 144, minus 144, cross you out, drop down the positive x squared, equals, and 169 minus 144 is 25. Now squared is in the way. I have to find x, not x squared. How do I undo a squared? Square root both sides. Now you may have learned in the past that whenever you take the square root of both sides to solve, you have to attach one of these guys, a positive or a negative symbol to the number, but we don't do that here. Why? Because we're finding the missing side of a triangle. So you're not going to say, my answer is positive or negative. Well, you can't have a negative side, so it can't be or negative. So my answer in this case is just positive 5. Now, since I'm given a unit of measure, I'm going to make sure I attach that in my answer. So find x. X is 5 inches. And that's my answer. We're done. Find x. We are being asked to find the missing side of a right triangle. Whenever I'm asked to find the missing side of a right triangle, we use this fella, the Pythagorean Theorem, invented by Pythagoras way back in the day. Now, a squared, b squared, and c squared, they are all representative of 3 sides here. Now, what letter gets what? Well, C has to be the hypotenuse, the longest side. The hypotenuse is always going to be the guy not attached to your right angle. Which one's A, which one's B? It doesn't matter as long as the longest side is C. So we'll call A 4, we'll call B 3, and we'll call C X. Now I plug them into the formula. A I called 4 squared. A fun game to play. B I called 3, so 3 squared, and C is x squared. Whenever you're doing the Pythagorean Theorem, whether it's you're finding a missing hypotenuse or a missing leg, the second step is always to simplify these numbers. 4 squared is 16, plus 3 squared is 9, still equals x squared. If you can combine like terms, combine them. 16 plus 9 is 25. 25 equals x squared. Now, I didn't find x yet. I have x squared. And in order to get rid of that squared, I have to square root both sides. Now, in the past, you were taught that if you take the square root of both sides in order to solve, you attach a positive or negative symbol to the number. We don't do that here because we can have a positive or negative side length. You can't have negative side lengths. It's only going to be positive. So we're not going to attach that symbol. So I'm sorry I even brought it up. But the square root of 25 is 5. The square root of x squared makes it just x. And what I'm going to do is I'm going to flip it around because I like my variable on the left, x equals 5. And I'm going to make sure I attach the unit of measure, which is miles in this case, because it's proper. But You are asked to find the missing hypotenuse. And in this case, finding the missing hypotenuse is Pythagorean Theorem, combine like terms, square root, you get 5 miles. I would walk 500 of those to answer another problem. It's a song, look it up. State if each triangle is a right triangle. This uses a little thing called the converse of the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Usually we use this guy to find missing sides of right triangles. Well, in all three of these cases, I'm given all three sides. So what I have to do is use this guy to make sure that these are right triangles. Now, what does that look like? I go to one of my triangles and I label the three sides A, B, and C. But oh, do be careful, because whenever you label A, B, and C, you must call the longest side C, because the longest side would be the hypotenuse in this case. It doesn't matter which one A is. It doesn't matter which one B is. And what you do, now that we have things labeled, is you plug it into this formula. So A squared is 12 squared plus b squared is 9 squared equals c squared is 15 squared. And you might be thinking, what are we solving for? Nothing. The goal of using the converse of the Pythagorean theorem is to make sure our math works out. If it does, it's a right triangle because it works for the Pythagorean theorem. If it doesn't, it's not a right triangle. It's still a triangle, but it's not a right triangle. So let's do the math. 12 squared is 144. 9 squared is 81. 15 squared is 225. 144 plus 81 is 225. Does 225 equal 225? Last time I checked, yes, it does. So this first one is a right triangle. Okay, let's try it again and again. So I have to label A, B, and C. Which one has to be A, B, or C? Well, A and B doesn't matter as long as you call the longest side C. So I'll call you A and I'll call you B. So 10 squared plus 49.5 squared has to equal 50.5 squared. 10 squared is 100. 49.5 squared is, let me do the math in my head, 2,450.5. And 50.5 squared is 2,550.25. I meant to put a 2 here. I don't know if I said it and just typed it or wrote it out wrong, but there you go. So, okay. 100 plus 2,400 blah is 2,500 blah. That equals 2,550.25. So since the both of them equal each other, even though I have a little writing errors here, I fixed it, and yes, it does work out. Okay, so not as pleasant, but I did the math in my head. I didn't. Last one. Now, I don't know what the square root of 115 is, but I do know that the square root of 121, which is 11, is 11. So this has to be C here because 11 is going to be bigger than the square root of 115 because 121 is 11. So I'll call you A, I'll call you B, and I'll set it up. And you might be thinking, oh, no, square roots. Don't worry about it. It's actually not bad. I have 9 squared plus the square root of 115 squared has to equal 11 squared. 9 squared is 81. 115 squared cancels each other out if I square root it. Happy days. 11 squared is 121. 81 plus 115 is like 196 or something, which is certainly not 121. So nope. All right, so this is how you use the converse of the Pythagorean theorem. I give you three sides. I ask you, is this a right triangle? You determine which one has to be C, and the longest one's always going to be C. You plug it in, you make sure it works, and if it does, it's a right triangle. If it does, if it's a right triangle. If it doesn't, it's not a right triangle. Not bad. State if the triangle is acute, like me, obtuse, or right. We know that we could use the Pythagorean theorem converse to determine if something is a right triangle by saying a squared plus b squared equals c squared. That's how you know if something's right. But how do you know if something is acute or obtuse? Well, if you take the sum of the two smaller sides, and that's what A and B represent, square them, if that sum is greater than C squared, you have yourself an acute triangle. Similarly, if I were to take the smaller sides and square them and add them together, and the sum of those is smaller than C squared, you have yourself an obtuse triangle. So I have to look at these, and I'm going to say that you're my A and you're my B. And if you're like, whoa, how did you figure that out? A and B doesn't matter as long as you call the longest side C. So I'm going to say, let me get a color I haven't used yet, 9.6 squared plus 18 squared is, I don't know, 20.1 squared. Once I find out that I don't know, I'm in great shape. 9.6 squared is 92.16. 18 squared is 324. And that is going to be 404.01 for 20.1 squared. If I add these two together, I get 415.16. 416.16. Yeah, that would make sense. And 416.16 is greater than 404.01. So since the sum of the two smaller sides was greater than the longest side squared, I have an acute triangle, which means all three angles are less than 90 degrees. Kind of tricky, but when you break this all down, you can kind of be like, oh, okay, I see what that guy did there. Find the area of this triangle right here. Well, the area of a triangle is 1/2 of base times height. I have a base, but you know what I don't have? I don't have a height. So what I can do is I can realize that this is an isosceles triangle, boom, boom, boom. And if it's an isosceles triangle, that means the height is going to go directly down the middle. So why don't I cross you out and say that one of these triangles right here is going to be 4.8. Nope, 3.8. 3.8. 3.8. Okay. So how can I find that height? I'll call you H. Well, if I split this big triangle into two smaller triangles, I now have a right triangle. And if I'm trying to find the missing side of a right triangle, I use an old friend called Pythagorean Theorem. A squared plus b squared equals c squared. I'm going to call you C because you represent the hypotenuse of this right triangle right here. I'll call you A and I'll call you B because it really doesn't matter which one's A or B as long as you call the hypotenuse C. So I'm going to call A H, so H for my height squared, plus B, which is 3.8 squared, is going to equal C, which is 5 squared. 3.8 squared is 14.44, so I will write that out. That's going to equal 5 squared, which is 25. In order to get h all by itself, I have to subtract 14.44 from both sides. So minus 14.44, drop down the h squared, and that's going to give us 10.56. Now, in order to get squared all by itself, I have to square root it. Not squared all by itself. In order to get rid of squared, I have to square root both sides. So that crosses out. I'm dealing with triangles, so I don't have to worry about this symbol right here. I've talked about that in previous videos, and if you're like, what? Never mind. I don't know what the square root of 100 or of 10.56 is, so I'm going to go off to the side and ask my phone. And it's awful. So it's 249615 blah blah blah. So I'll do 3.25. I think that should do it. If it's 3.296, I think 3.25 should do it. 3.2496, that should do it. So that represents the height of my triangle. So let's get rid of all this stuff now that I've gotten rid of it. Okay, what do I know? Well, I now know my height is 3.25. Ish. I have my height. I have my base. Let's plug it all into the formula. A equals 1/2 of my base, which is 7.6, times my height, which is 3.25. I have zero clue what this is off the top of my head, so I'm going to go off to the side and ask my phone again. And the old phone says 12.35. So I'm not going to circle that. Most teachers would be fine with it, but I'm going to say my area is 12.35. I look up here for units. I don't have any, so I will say units squared, because whenever you're given area, you should give some type of unit, even if you're not given a unit. And when you're finding area, it's always units squared, feet squared, inches squared, whatever. Okay, but that's how we find the area using Pythagorean Theorem. Find the perimeter of the larger triangle. All right, let's see. I have 42, 26. This chunk is 11, but I don't have that part right there. Well, what I have is I have two right triangles inside a larger right triangle. Maybe this might not even be right. Who knows? It may not be. It doesn't matter. All I know is that this is a right triangle. That's a right triangle. So what I can do is I can find this missing side right here by using Pythagorean Theorem. Once I find that missing side, I could use Pythagorean Theorem again to find that guy. Add all four of these sides up, and I have myself my perimeter. So let's do that. Let's find this missing side right here using Pythagorean Theorem. Let's give it a name. Let's call it h, because it's the height of this triangle. That way, when I use Pythagorean Theorem twice, I'm not super confused with the letters that I used. So I am going to use Pythagorean Theorem. A squared plus b squared equals c squared. Now, looking at this triangle right here, this little one with h 11 and 26, I know c has to be my 26 because c always has to be the longest side, the side opposite of my right triangle. It doesn't matter which one's a or b as long as the longest side is c. So a is h squared, so h squared plus b is 11, so 11 squared is going to equal c, which is 26, so 26 squared. H squared doesn't change. 11 squared is 121. That's going to equal 676. Now, in order to get h all by itself, I have to get rid of squared and I have to get rid of minus or of regular 121. And I do that by minusing 121. I was getting ahead of myself. Got excited there. So let's subtract 121 from both sides. H squared is going to equal 555. Square root both sides. And I have zero clue what the square root of 555 is, so I'm going to go off to the side and do that. So it's gross, and I knew it would be gross. That's kind of why I took a moment to figure out what this was, because I thought I was going to get something pleasant, and I didn't at all. It's 23.558, so let's go with 23.56. So this guy is 23.56. All right. That guy, the height. Yippee. Now, I'm going to do the same exact thing to find out this part right here. So I'm just going to call it X. All right. I am now focusing on this triangle on the left where I have a height of 23.56. I have a hypotenuse of 42, and I'm missing a length of X. So I'm going to use Pythagorean Theorem again, using different colors so I don't mix the two A, B's, and C's. I will call you A again because, why not? I'll call you B as long as I call the longest side C. So A is 32.56, 23.56 squared. Plus B is, X squared equals 42 squared. Before you reach for a calculator, we know what 23.56 squared is. It's 555. We just did that. Oh, yeah. Plus X squared is going to equal 42 squared, which is 1,764. Subtract 555 from both sides. Subtract 555 from both sides, and you're looking at 9. Carry the 1, make that a 2. 1209 gross is equal to X squared. Is X all by itself? No. Squared's in the way, so let's square root both sides. No clue what the square root of 1209 is, so I'm going to go off to the side. It's gross. It's 34.7706777301. So I'll put 34.77. So this guy right here, and I'll make it black, is 34.77. So in order for me to find the perimeter of this whole triangle, I have to add that side plus 26 plus 11 plus 34.77. 42 plus 26 plus 11 plus 34.77. That's going to end up equaling 113.77. No units to worry about, so units, feet, inches, whatever. Just don't square it because we're not finding area, we're finding perimeter. Pretty gross problem. Not a big fan, took a while, but yeah, I got it. I got it good. Find the missing side lengths. So with this problem, we are going to use special triangles. Those of you who are like, I did geometry already, and I'm using this as a refresher course, don't do trigonometry here. And if you've never taken trigonometry before and you're like, the heck? Then we're going to use what's called special triangles. There's two types of special triangles, but the one we're going to focus on right now is the 30, 60, 90 triangle. The 30, 60, 90 triangle is named 30, 60, 90 because it has measures of 30 degrees, 60 degrees, and 90 degrees. When you're doing a 30, 60, 90 triangle, the smallest side, the side in between 60 degrees and the right angle, is going to be A. We'll just call it A. In this case, 2. The other leg is going to be whatever the smallest leg is multiplied to the square root of 3. The longest side, the hypotenuse, is going to be whatever the shortest leg is multiplied to 2. This is the rule for the 30, 60, 90 triangle. The smallest is whatever it is To find the other leg, you multiply the smallest leg by the square root of 3. And to find the hypotenuse, you multiply the smallest leg by 2. So, in order to find V, V is going to be the other leg. The smallest leg is 2. So V is going to be the smallest leg multiplied to the square root of 3. And that's it. Don't run your calculator. Don't type it out. We're going to leave it like that. U is much friendlier. U is going to be the smallest leg times 2. So 2 times 2, let me get out my calculator, is 4. So my smallest leg is 2. My other leg is 2 square root of 3, like that. And my hypotenuse is 2 times my smallest leg. 2 times 2 is 4. This is how you use the 30, 60, 90 triangle to find the missing sides. Find the missing side lengths. All right, what we have here is a 30, 60, 90 triangle. There's a little rule that says if you're given a 30, 60, 90 triangle, okay, we'll call you 30 degrees, we'll call you 60, and you're going to be my 90. You find out what the smallest leg is, call it A. The other leg is going to be A times the square root of 3. The hypotenuse is going to be 2 times A. That's how you deal with the 30, 60, 90 triangle. It's a shortcut, okay? Those of you who are using this video as a refresher, if you're thinking, oh, I'm going to use SOHCAHTOA, don't. You could, but don't. If you have no clue what SOHCAHTOA is, pretend I didn't say that. Now, what do we have? We have the hypotenuse. We're not starting out with the smallest side. Okay, that is my smallest side. That is my A. Okay, so I'm working my way backwards. Well, let's use common sense. Okay, if the longest side, the hypotenuse, is 2 times the smallest side, then in order to find the smallest side, we go in reverse. Divide 16 by 2, which according to my brain is 8. And you're thinking, oh, this isn't bad. I can find x easily. Hold your breath a little bit because this one's not going to be so pleasant. Actually, I take it back. I now have the smallest side. I have the smallest side. The smallest side is 8, which means to find the other leg, all I have to do is multiply the smallest side by root 3. So I'm done. What I was initially thinking is I was going to take that 16 divided by root 3. And you might be thinking, isn't it bad to divide by square root? It is. Because you have to do all these little extra rules called rationalizing the fraction, but we didn't have to do that here because I was a little more clever. Again, what I did is I was given the hypotenuse. I know the hypotenuse is 2 times the smallest leg, so the smallest leg is half the hypotenuse. Dunzo. Y is 8. Once I have the smallest leg, I know that the other leg is just root 3 times the smallest leg, so root 3 times 8 is 8 times root 3. And if I wanted to, I could have found x by dividing by root 3, which would require me to do a little bit of extra work, but didn't. So I'm done. Find the missing side lengths. What I have here is a 45-degree angle and a 90-degree angle, and common sense tells me you're also going to be 45 degrees. This is a special triangle called the 45-45-90 triangle. 45-45-90 gets its name from the fact that I have a triangle with a 45-degree angle, another 45-degree angle, and a 90-degree angle. The legs here, since this is an isosceles triangle, are exactly the same. So I'll call you A and I'll call you A as well. The hypotenuse, if you're thinking, oh, I'll just do Pythagorean Theorem, don't worry about it, because after you do Pythagorean Theorem, you're just going to multiply the square root of 2 to the smallest leg. That's kind of the trick. That's why this is a special case right triangle. So over here, I have a leg of 2 times the square root of 2. Well, if one of my legs is 2 times the square root of 2, that means B, the other leg, is also going to be 2 times the square root of 2. Bada bing. Now to find the hypotenuse, which is A, I'm going to take my smallest leg, both of these are the same, so they're both the smallest leg, and I'm going to multiply it to the square root of 2. So the square root of 2 times the square root of 2 means you can multiply inside the square roots and get the square root of 4. Oh, I know what that is. The square root of 4 is 2, which makes A equal to 4. So this is a special case triangle. It's a 45, 45, 90. And when you have a 45, 45, 90, whatever one leg is, the other leg is also. And to find the hypotenuse, you just multiply a leg by the square root of 2. And in our case, we had to do a little bit of clever math, but it really wasn't that bad. And we're done. Find the missing side lengths. All right, I have a triangle. That's 45 degrees. That's 90 degrees, which means you're 45 degrees as well. Now, this is a special case triangle called the 45, 45, 90 triangle. It's called 45, 45, 90 because the angles are 90 degrees, 45 degrees, and again 45 degrees, which means it's isosceles, which is good because whatever one leg is, the other leg is exactly the same. If I'm given a leg, what I can do to find the hypotenuse is take that leg and multiply it to the square root of 2. So if you're thinking, this is pretty simple, just take a leg and multiply root 2 to it to get the hypotenuse, I'm done. Great, except this one's not that simple. See, I'm given the hypotenuse. I need to find both legs. X and Y are going to be the same thing. So once I find X, I have Y. The problem is I'm starting out with a hypotenuse. So if I'm given a leg and I multiply square root of 2 to get the hypotenuse, then in order to get the leg from the hypotenuse, I divide by the square root of 2 because I'm working in reverse order. Now, when you have a square root and you divide by a square root, we can shove 2 off to the side and divide both of these guys within the single square root. So you get 6 divided by 2 inside the square root. Last time I checked, 6 divided by 2 is 2 times the square root of 3. And so my X and my Y are both going to be 2 times the square root of 3. So there are times where you use special case triangles like this one, and you're given the leg, and it's easy. When you're given the hypotenuse, you have to work in reverse, which means you divide by the square root of 2. And in our case, it still ended up being a fine number. If you're like, oh, let me whip out my calculator and find out what that is, don't. Okay, whenever you're dealing with right triangles, you're going to see square roots quite often. Don't lose sleep over it. I certainly won't. Neither should you. Find X. All right, there you are. Let me see. I have 2 triangles attached to each other. X is way up here where the only information I'm given is 90 degrees and 45. Oh, that makes you 45. Great. But that's not enough information to give me any lengths here. So let me go to this other triangle, which is 45 and 90. So you're 45. Okay. Now, there's a little rule when you're given triangles that are 45, 45, 90 that we can use, and that uses the special case triangle 45, 45, 90. The 45, 45, 90 triangle says that if you have a triangle where your angles are 90 degrees and 2 45s, if I give you a leg, we'll call it A. The other leg has to be the same exact thing because this is an isosceles triangle, which means these angles are the same and the legs are the same. In order to find the hypotenuse, you take the leg and you multiply root 2 to it. So whatever this leg is times root 2. So I have one length here and it's 7. So since this is 7, just for funsies, I will say that that is 7. Does that help me? No. What will help me is the fact that this will be the hypotenuse of this bottom triangle here. That's the hypotenuse. 45, 45, 90. The hypotenuse is square root of 2 times a leg. So you are 7 root 2. Done? Nope. Because my next step is, now that I have that little piece of information, I could use this triangle right here and find my missing hypotenuse. So if you're 7 root 2, just for funsies, I can say that you're 7 root 2. Does that help me? No. But what I do know is that this is a 45, 45, 90. And according to the 45, 45, 90 rule, if whatever one of the legs are, I just multiply it to root 2. So x, my hypotenuse, is going to be one of the legs, that's the leg, times root 2. So I have 7 times the square root of 2 times the square root of 2. If you're multiplying two square roots together, just multiply the insides and keep that square root there. So 2 times 2 is 4. I know what the square root of 4 is. It's 2. And I know what 7 times 2 is. It's 14. So x is 14. Any units? Nope. So that's my guy. So I use special case triangles to find the missing side when I'm given two triangles glued together. Fun. Find x. All right, what do I have here? X is way over here. It's attached to this little triangle-looking thing that has an angle of 45 and 90. Oh, which means you would also be 45. Do I have any information about this triangle? No, I just know that it's a 45, 45, 90. Great. Let's look at this other triangle. I have the hypotenuse of this triangle. It's 90, it's 45, and it's 45 again. So I have two 45, 45, 90s. I know that 45, 45, 90s are special types of triangles. Okay, it's a special type of right triangle that says that's supposed to be 45, 45, 90, poorly drawn. But it says if I have a triangle with 45 and 90 degrees, if I have a leg here, the other leg is exactly the same because this is isosceles. Also, the hypotenuse is going to be square root of 2 times a leg. So if this was 5, 5 root 2. Got it? Now, how does that help me here? Well, I have to work my way from 7 root 6 all the way to x, which means I probably have to find that line connecting it. So what I'm thinking is I'm going to start out looking at this big triangle right here that is 45, 45, 90. I have the hypotenuse. The hypotenuse is 9 root 6. I need a leg. Over here, I said, if I give you a leg, then the way I find the hypotenuse is I multiply by root 2. Well, this is not simple because I'm not giving you the leg. I'm giving you the hypotenuse, which means I have to go in reverse. So I'll call you h because it looks like it could be a height. So I'm just going to call it h. In order to find h, which is a leg, I have to take this hypotenuse and divide by root 2 because I'm working in reverse. So my hypotenuse is 9 root 6. I'm going to divide by root 2. Now, when you do a square root divided by a square root, I can take this 9 here and shove it off to the side and put both of these numbers inside the same square root. What that gives me is 9 times the square root of 6 divided by 2, 3. So this value right here, that h, is 9 root 3. For funsies, this is also 9 root 3, but it doesn't really help us. Now what I have is I have this triangle where I have to find x, so I'm going to color it blue. Okay, and what I'm going to do is, just because I'm mucking this up, I'm going to move it down. I'm going to recreate the fact that this is 9 root 3, and I have to find x, and you're a right angle. You're 45 degrees, you're 45 degrees. I'm given a hypotenuse of 9 root 3. This is a 45, 45, 90. I know that if I was given a a hypotenuse and I have to find the leg, I divide by root 2 again. So x is going to be 9 root 3 divided by root 2. Now here is the problem with this guy. If I use the same process that I did here, nothing's going to simplify. I knew that I could do 6 divided by 2, and so I did this. You're not allowed to have the square root of 2 in the denominator of a fraction. So when you have the square root of 2 in the denominator of a fraction, what you do is a process called rationalizing the fraction. You multiply the top and the bottom by the square root of 2. What does that do for us? Well, the top becomes 9 times the square root of 3 times 2 is 6, the square root of 6. Anything there change? Nope. The square root of 4. And if you're thinking, why does that help us? I thought I was supposed to get rid of the square roots. What's the square root of 4? 2. So 9 times the square root of 6 over 2 is now a legal answer. And so that's my x. And if you're thinking, oh, can I simplify these? No, because one's in a square root, one's not. So this problem was much more complicated than a previous video that I had, but the same idea is there. It's just with this one, I'm giving you the hypotenuse instead of giving you a leg. So complicates things a little bit. Still tons of fun. I enjoyed it. Find x. There you is. What do I have? I have a big triangle, this triangle glued to that triangle. All right, I have 9 root 6, and x is way over here. So x isn't attached to 9 root 6 really in any way whatsoever. What do I know? X is attached to a triangle that has a 90-degree angle and a 60-degree angle, which means you're a 30-degree angle. Oh. I'm probably going to end up using the 30, 60, 90 triangle. So let's draw that out. 30, 60, 90. The 30, 60, 90 triangle says that if I have a triangle with a 90-degree, a 30-degree, and a 60-degree, whatever the smallest leg is, I'll call you A, the hypotenuse is going to be exactly 2 times that smallest leg. The other leg is going to be the square root of 3 times the smallest leg. So what I'm going to do is I'm probably going to end up using those facts for this guy, but I can't even begin this guy until I figure out what I have over here. My 9 times the square root of 6 is attached to this leg of this right triangle that has an angle of 60 degrees. So that means you're 30 degrees as well. So this is the longer side of a 30, 60, 90 triangle. So what I have to do is work backwards a little bit. I have to work backwards to find this guy right here. I'll call you A. A, in my case here, represents the smaller leg of this right triangle. Now, if I were to find the bigger leg of a right triangle that's 30, 60, 90, I multiply by root 3. So if I wanted to work in reverse and say, let's now go from the big leg to the small leg, that means I have to take 9 root 6 and divide by root 3. So again, I called A, this leg right here. You are now 9 root 6 divided by root 3. 6 over 3 is doable, so what I'll do is I'll just move the 9 off to the side. There's a rule that says if you're dividing square roots, just make it one big square root and divide on the inside. So 6 over 3 inside the square root. 6 over 3 is 2. So that length right there is 9 root 2. 9 root 2. This is not going to be pleasant at all, because now I have part of this guy right here. Now I'm looking at my smaller right triangle right here. Gross. Can't draw at all. So what I can do is let me redraw it, make it a little bit bigger, make it a little bit more pleasant to look at. You're 90, you're 60, you're 30. You are now 9 root 2. I need to find u. I don't know u. So just like this guy, I'm given the larger leg. And in order to find the hypotenuse of a 30, 60, 90 triangle, I have to deal with the smaller leg. I have the larger leg. If I'm given the larger leg and I have to find the smaller leg, what do? Let's call it b just for funsies. B is going to be 9 root 2 divided by root 3, just like we did up here. There's a problem, though. I could do 6 over 3 and make it go away. I can't do 2 over 3 in roots. So what I have to do is I have to rationalize the denominator, rationalize the fraction. I have to get rid of that square root of 3 because you're not allowed to have square roots of 3 in the denominator of a fraction. So the way you get rid of it is you multiply the top and the bottom by the square root of 3. This is going to make you happy. You'll see why in a moment. Okay, b is going to equal 9 times the square root of 2 times the square root of 3, which is the square root of 6. When you're multiplying square roots, you multiply within the roots and make it one bigger root. The square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. So b is 9 root 6 over 3. 9 and 3 don't have square roots. So I can simplify 9 divided by 3 and make it just 3 root 6 because 9 over 3 is 3. So this guy, my smaller side, my smaller leg is 3 root 6. So if I have a 30, 60, 90 triangle and my job is to find the hypotenuse and I have this smaller leg, I'm finding x now, I take this smaller leg, 3 root 6, and multiply it by 2. 2 is outside the square root, so is 3. So 3 times 2 is 6. X equals 6 root 6. No units, nothing like that. We use special right triangles in order to find missing parts of two right triangles glued together. Fun, 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 fun.